Okay, Assalamualaikum and good evening. My name is Muhammad Shafiq bin Hamsani. My matrix number 191291929. Okay, so this is my presentation video for my CAA 2 PLT 203 Electronic 2. So let's we go for the introduction. Uh, we will discuss about the solar tracker. So basically, as we know, there are two main types of solar tracker that are available on the market, which is the single and the dual axis. Okay, for the single axis solar tracker, it will track the sun east to west, which is rotating on a single point, moving either in unison by panel row or by section. Furthermore, single axis tracker will gather less energy per unit compared to dual axis tracker, but with shorter racking height. They require less space to install, and then it will creating a more concentrated system footprint and easier model for operations and maintenance. So we will see about the second one, which is the dual axis. Dual axis tracker rotate on both the x and y axis, and it will making penetrate the sun directly. uh, Dual axis tracker also used more in residential and smaller commercial application, but uh, are beginning to see utility scale development. Second one, let's we see all types of material that I use in my project in order to design the solar tracker circuit, which is the first one is the breadboard. Second one, we use the resistor. Third one, power supply, photoresistor, or the other word that we call LDR. At the NPN, the both type NPN and PNP BJT, bipolar junction transistor. The motor DC, diode and operational amplifier. We use the OM 741. So for the method, okay, first we can see this is my circuit that I managed to design by the Proteus software. So okay, the first one, this is my step. Overall I have 4 steps, so we will see step by step. The first one, which is the step 1, is design the circuit. Okay, based on the circuit above, we need to design the same circuit in the Tinkercad. Okay, and then we need to ensure that we use the right component. We need to ensure that all the connection is correct. Okay, for the step 2, set up the component and the detailing of component. Okay, we need to set up all the value of resistor to 10 kilo ohms, and apply the resistor or LDR as detector of light. Basically we use uh, 2 resistor or 2 LDR in our circuit. Then we set up the power supply to 12 volt. Okay, and then apply the diode to allow the current flow in one direction. Apply the NPN and PNP bipolar junction transistor or BJT, and apply the motor DC as the load. Okay, for the step 3, we need to run the simulation, which is we need to run the simulation in the Tinkercad. The first thing, we need to adjust the first LDR to see the result based on the motor DC. And then second step, we repeat the same step, which is we adjust the second LDR to see the result based on the motor DC. Okay, for the step 4, that we see the last step, which is the result and the report. And what we need to do is just based on the result of simulation, make a full report about the project and discuss about the detail of project. Okay, this is for my result circuit. So basically this is from the Tinkercad, the first result. Okay. Okay, this is the explanation for the first LDR. Okay, the first LDR, which is the first position of LDR, is represent the waste side. Okay, when we run the simulation, we need to adjust the LDR or the photoresistor at high or the maximum point as the represent of the presence of light. And then as we know, the photoresistor is the detector of light. Or in this case, we mentioned about the solar. Okay, therefore, when there are presence of light, uh, the motor DC will rotate to the clockwise direction. Okay, that we can see based on the uh, shown error. Alright, then the higher of the power supply will increase the rotation of the motor DC. Okay, then we will see the next. This is the next picture for the second result, which is the second LDR is at the right side. Okay, the first LDR is the left side. We can see the we set to the max or the high level for the first at the left side, and the second one we set the LDR to the maximum level of the right right one, the second LDR. Okay, for the second LDR, the second position of LDR is represent the east side. When we run the simulation, we need to adjust the LDR at the high or the maximum point as the represent of the presence of light. And then as we know, LDR is the detector of light, which is uh, I just mentioned that in this case we mentioned about the solar. Okay, and then therefore when there are presence of light, the motor DC will rotate to the anti-clockwise direction. Okay. Okay, the higher of the power supply will increase the rotation of motor DC. Okay, then for my conclusion, at the end of this project, I am able to design the circuit of solar tracker completely. Moreover, I am able to understand the function and rules of each component that I use in the circuit, which is in the circuit we use uh, the operational amplifier 741, and the main point we use the LDR to detect the presence of light. Then I also can apply my theory knowledge about the operational amplifier in this project, which is the main component that we need to use after the LDR component. Okay, that's all from to me. Thank you.